Ever wonder how a video game knows you've won? Or how your phone reacts the instant you tap a button? Well, at their core, those are just decisions. And today, we're going to pull back the curtain and see exactly how we teach a computer to think, to make choices, using the C programming language.
So here's our game plan. We'll start with how a program normally runs, and then we'll introduce our very first decision-making tool, the if statement. From there, we're going to build up our skills, handling multiple paths and more complex choices, and figuring out which tool is the right one for the job. By the end, you'll see how these simple ideas are the foundation for some seriously smart software.
You know, by default, a C program is kind of like a super obedient robot with a to-do list. It starts at the first line, does that, goes to the second line, does that, and on it goes in a perfectly straight line until it hits the end. No questions asked, no detours.
And that brings us to a huge problem, right? A program that just follows a list is fine, but it's not very smart. We need our code to be dynamic. We want it to check if a password is correct or react to a player's score in a game. So how in the world do we do that?
Well, the answer is something called control statements. Think of these as the special commands in our programming toolkit that let us break that straight line. They give our program the power to look at a condition and say, okay, based on this, I'm going to jump over here, or I'm going to skip these next few steps. They let it make choices.
All right, so let's dive into the most fundamental, the most important control statement of them all. This is the absolute bedrock of decision-making in code, the simple but incredibly powerful if statement.
The logic here is just so intuitive, mostly because you and I use it every single day. The action, grabbing an umbrella, only happens if a specific condition is met. It's raining. If it's sunny outside, well, you just ignore the whole umbrella part and keep going. Simple as that.
And that is precisely how it works in C. An if statement checks a condition, and if that condition is true, it runs a block of code. Now here's a really key detail for C programming. True just means any number that isn't 0. That's it. It's a simple idea, but it's totally fundamental to how C thinks about logic.
And check out the syntax, it's so clean. You just have the keyword if, then you put your test, your condition inside parentheses. If that test passes, boom, all the code between those curly braces gets to run.
So what you have here is basically a one-way gate. The program gets to the if, it checks the condition. If it's true, the gate swings open and the program runs the code inside. But if the condition is false, that gate stays shut and the program just walks right on by, skipping that code completely.
Okay, the if statement is great, but it really only tells the program what to do if the answer is yes. It's got a blind spot. What if we need a specific alternative action for when the answer is no? Well, that is where if-else comes into play.
Let's go back to another real-world example, a traffic light. You have two very clear instructions, all based on one single condition, the color. If it's green, you do one thing, you go. If it's anything else, you do a different thing, you stop. There's no option to just do nothing.
And that is the whole job of the if-else statement. It sets up two totally distinct paths for your program. It looks at a condition and then it guarantees that one and only one of two code blocks is going to run. It covers all the bases, both the yes and the no.
So this creates a very clear fork in the road for our program. It tests the condition. If it's true, it's forced down one path, it runs the if block. If it's false, it's forced down the other path and runs the else block. The key is it has to choose one. It can't skip both.
Let's be real, life is rarely a simple yes or no, and programming is exactly the same. What happens when you're grading a test with A, B, C, D, and F? Or choosing from a menu with 5 options? You need a way to handle way more than just 2 possibilities.
So for this, C gives us two main tools. Over on the left, you've got the if-else-if ladder. It's basically like stacking up a bunch of if statements to check different conditions one by one, right down the line. And on the right, we have the switch statement. This is a more specialized tool for when you need to check one single variable against a list of very specific values.
Now, the switch statement is incredibly powerful, but you gotta know it's a bit of a diva. It has some very specific rules. It only works with integers and characters, and the cases you're checking against have to be constants. But the most critical rule, the one that trips up everyone at some point, is the break keyword. If you forget to put break at the end of a case, the program will run that code and then just fall through and run all the code for the cases below it. It's a super common bug.
Okay, so we've got two different ways to handle multiple options. How do we decide which one to use? This isn't just about style.
It's about picking the right tool for the specific job you're trying to do.
And this is the real, practical question every programmer has to answer. Is one really better than the other? Does it even matter? And the answer is a huge yes. It absolutely matters. It can impact not just how clean your code looks, but how fast it runs.
So let's break it down. The if-else ladder, that's your flexible workhorse. It can handle all sorts of complex logic, like checking if a value is greater than something or less than something else. The switch statement is much more rigid. It only checks for equality. Is this variable equal to 5? Is it equal to A? But in exchange for being so picky, it's often a lot faster, because the compiler can sometimes build a jump table to go directly to the right answer, instead of checking every single condition one by one. This makes it perfect for things like user menus.
So the bottom line is this. If you're checking ranges, like a test score between 80 and 90, or any kind of complex condition, you need the flexibility of an if-else ladder, period. But when you're checking a single variable against the list of specific known values, like menu option 1, 2, or 3, the switch statement is almost always going to be the cleaner, faster, and just plain better choice.
Wow, we've covered a lot of ground, right? We've gone from a program that could only walk in a straight line to one that can make complex branching choices. These control statements are the tools that take a program from being a dumb script to a truly intelligent application.
So, to wrap it all up, here's your cheat sheet. Use a simple if when an action is totally optional. Use if-else when you have a mandatory choice between two things. Use the if-else-if ladder when you have multiple complex conditions to check. And grab that switch statement when you need a fast, clean way to choose based on a single variable's value.
And you should never forget this key idea. Every single app, every operating system, every complex piece of software you use every day is built on top of these fundamental decision-making tools. Mastering them isn't just about learning C. It's about taking your first real step toward mastering programming itself.
We've walked through the concepts, the syntax, the strategies. You now have the fundamental building blocks for making programs smart. So the only question left is, what are you going to build with them?